Welcome everyone. Today we will learn Oracle SQL language. By the end of this course, you will be able to write the basic SQL queries in database. What we learn from this course: SQL introduction, SQL data retrieval technique, SQL detail commands, DML commands, integrity constants, built-in function, data aggregation, join, set operators, pseudo columns, subqueries, database transaction and security, and design of schema objects. What we learn from this video: SQL introduction. Which topic we will cover in this video? What is SQL? Why SQL? SQL commands. What is RDBMS? Table, field, record, column, database normalization. What is SQL? SQL is structured query language, which is a computer language for storing, manipulating, and retrieving data stored in a relational database. The simple word: structured query language. In a software, there are two parts. One is front end, another one is back end. Front end means through which users can give some data into the computer, means inserting some data into computers, or we are taking some data through front end from user using front end. Then what will happen with that data? We are passing that data into our back end. Means we are passing all those information which we took from users, and we are passed that one to our database to store that one in our database. This process is called as back. And how we are passing that data from front end to back end? Using SQL, that is structured query language. Suppose in some of the cases we want to retrieve data from database to front end. That time also we are using structured query language, which is SQL. So SQL, you can say, the pull between front end and back end. If it is a front end in one side of a river, another side of river is back end, and in between some river is going, and you want to build some pull between this front end and back end, both the side, then that pull is known as SQL. That is structured query language. Structured query language is, it's a, you can say, common language which is derived by or which is used by Oracle, Microsoft, and they built their databases. So more or less syntax for Microsoft, for Oracle, is almost same. Right now in this video or in this tutorial, we will follow Oracle SQL structured, but you can use the same query in Microsoft also. That will also work. Some of the cases it will not work. You have to go to change the syntax of for that Microsoft. That's it. But concept is absolutely same for any of the database. Why SQL? SQL is widely popular because it offers the following advantages: allows users to access the in the relational database management system, allows users to describe the data, allows users to define the data in a database and manipulate that data, allows to embed within other languages like using SQL modules, libraries, and precompilers, allows user to create, drop database and tables, allows user to create, view, store procedure function in a database, which is we can use known as a PL/SQL, programming language, structured query, query language, allows users to set permission on tables, procedures, and views. After this SQL, we will learn PL/SQL, which is the programming concept with SQL. Means you can write some program using SQL, and with that some ERP modules. You can see they are using PL/SQL in their base, like Oracle applications. It's a Oracle application. It's one of the famous job in industry, which is actually based on ERP, Oracle ERP system, and they have their own front end, they have own their back end. So Oracle application totally built on PL/SQL. So if you know SQL, then go for the PL/SQL course also, and with the combination of this SQL and PL/SQL, you can go for backend developer in your in industry. So it's a good career path in IT industry, the backend developer. Um, I am also a backend developer, and that's why I have more than 15 years experience in this industry, and I can tell you that it's a very good job opportunity if you learn well enough SQL and well enough PL/SQL, and you know you can go for Oracle application framework, and with that you can start your career path. So let's see some history of SQL. 1970, Dr. Edgar F. Ted Codd of IBM is known as the father of relational database. He described a relational model for databases. 1974, structured query language appeared. 1978, IBM worked to develop Code's idea and released a product named as System R. 1986, IBM developed the first prototype of relational database and standardized by ANSI. The first relational database was released by relational software, which later came to be known as Oracle. So you can say that Oracle is the father of the relational software or database software in this backend uh, industry. Before starting with the SQL process, let me tell you what. Let me tell you how SQL is running in computer. When you are executing an when you are executing an SQL command for any RDBMS is means relational database management system. The system determines the best way to carry out your request, and SQL engine figures out how to interpret the task. There are various components included in this process. These components are query dispatcher, optimization engine, classic query engine, SQL query engine, etc. etc. A classic query engine handles all the non-SQL queries, but a SQL query engine won't handle logical files. Following, it's a diagram, you can say in the screen, it's a diagram showing SQL architecture. First is SQL query, which is passed into the query language processor. Inside of query language processor, parser and optimizer will run. Then it passes to DBMS engine, where you can pass file manager, transaction manager. Then it is passes to physical database. From there, you can retrieve the data or push the data through SQL. So this is how this SQL is processing. Let me show you one of the all the commands one by one. So SQL commands is based on three parts: DDL, DML, DCL. DDL is data definition language, DML is data manipulation language, and third one is DCL, data control language. So what do you mean by data definition language? Suppose you are starting with one particular subject. you're starting with one particular subject. At the beginning of the subject, what you learn first? The definition of something. Like suppose you are starting with light in physics. So first word in your book is that what is light, and that means you are going for definition of light. Same thing for our database. You can think about our database is a open ground. It's a fully open ground. They have nothing in that ground. It's only totally, you can say, only grasses in that particular ground. So, and you have opportunity to create some building over that ground, and you can store someone, you can give that building to someone to live. So it's very simple. The ground is a schema, or a database. Over top of that one, if you build any building, that means it's we are building a table or view, whatever, an object. You can say an object. Then, if you are storing, if you are giving that building to any person, means the person is going to take that building and and started staying there. That means you are inserting some data into table, and in that table the data will reside. Suppose after 15 years you are destroying that building, means you are dropping that table. So this is how the definition, data definition, you can say in SQL commands. When you're creating that building, you are using create command. One door is broke in your building, and you want to change that door. You are altering that table or altering the building. So you are using alter command there. After 15 years, or you say that after 1 year also, or you can say after creating that building, you don't want that building and you want to destroy that building. So you are dropping that building from the database, from the field. So you are, if you want to drop the table, then you have to use drop as a command. So these three things are known as data definition language, which directly impact your structure of any table or any object. Whenever it is directly attack or directly impact on your object in of your database, then it's known as a data definition language part. Like create directly impact on table in your database. So it's in DDL definition language. It's in DDL definition language. Alter is also directly impact on your object. That's why alter is also in data definition language. Drop, it's also directly impact on your data definition on your object. That's why it's in data definition language. This is how you can bifurcate all these commands. Which one is in data definition language, which one is DML language, which one is in DCL language, like that. So let me show you three examples to for that DDL command. So let's start with DDL. So first DDL command we learned that is create. Then I'm going to create one table, means one building I'm going to create in our field or in our database. So I'm putting that create table. You have to give proper name, like which describe that what is that table means, or what type of data it's in, what type of data is in that table. So I'm giving it like I'm trying to create a customer table. So customer, then I have to tell what are the columns I want to put into that. I want to put into that table. So I have to define that column. Here you can say like customer is a total full building. Then one floor will contains the different rooms, which means different columns. So ID one of the column, and that will be number. So first I am giving the name of the column, then I am giving the data type of the column. What is column? That I will tell you later. Yes, then I am putting the second column name is like customer name. I'm putting cust ID. Cust ID is better. Cust underscore ID is number, customer name. Then varchar 2. Then I'm giving size. What is those things? Number, varchar 2, that I will also explain later. Just this is the, you can say that these are the data types of your column. Means what type of data you can store in that particular column, or in that particular room, what type of data you can put in this table. Then I can write like customer ID, customer name, um, customer salary. Not customer salary, it's not there. Customer uh, address, line 1. Then customer zip, then customer status, okay, and the customer creation date. I'm putting customer creation date. That's it. And then I want to execute this one into the database. Session is expired. Let me refresh the session. Okay. So I'm running this one. Table is created. So if I want to see that table is created or not, I can like do this one. Customer. Okay. So this one using is come because I'm putting run, and it is going to execute all these lines. So when it is going to execute this one, it's already we created. That's why it is showing it's already existing object, and they have no record till now. I'm inserting into the customer table, so that's why it's showing no data found. So fair enough. Now, if I want to alter the table, means if I want to put some more column, in this customer table, then or I am then I have to write this one, alter table customer, add customer phone number. That is also varchar 200. I'm not running this one. I am closing this one, commenting this one. and I want to run only this thing. Table is altered. Now, if I query this one, still it will not give any data because they have no record in this table right now, but the column is added into this table. So first one is create table, second one is alter table, and now last one I will go down, last detail, that is drop table. I am dropping this table, drop table, then customer. I run this one, then this table will be dropped from our database. Means the building is destroyed from the field. So there's no table with customer name. So if I run this query, customer, then tabular view does not exist because I already dropped that building from the field, or I destroyed that building from the database. So that's why this table is not found when I'm querying that from the in the database. So this is how DDL commands are running: create, alter, drop. I guess you guys got this DDL commands. Now the second part is the DML language, DML, data manipulation language, which is select, insert, update, delete. Some of the cases you can say select as a DQL, data query language. It's select as in part of DQL, data query language, or some of the cases you can say that they have no DQL thing. The select is in DML command. So first, I will tell insert. Your building is already created. You created the rooms in that building. Now you are giving that particular floor to a person, that this first floor is for you, the second floor for another person, the third floor is for another person, the fourth floor for another person, like that way. So that when you're giving that first floor to one person, that means you're inserting someone into your building. The same thing follows in SQL also. When you are trying to, after creating the table into database, into database, when you're trying to insert some record into database, that means you are inserting one records through DML language. Next one is update. After inserting record into the database, say one of the room you don't want to put you want to change the person from one room, then you are updating that table, you are updating that building with some new value. That means you are performing update commands, update DML commands in your database, which will modify the records. After inserting, you don't want someone into the table, or you don't want one person into your building, so you want to delete that one you want to delete the particular person from the building, then you are performing delete command in your database, like in your table. So the delete command goes for the DML, or you are manipulating that person from your table, the record from your table, then we are using delete command. So insert, update, delete, select, with all this you are actually manipulating the data. So that's why it is known as DML, data manipulation language. Now let's see some example. First I will create again back the customer table. I'm running this one. Table is created. Now I'm inserting one record into the customer table. I'm going to run this query now. Let's see. One row inserted. Great. Then I want to see that query and see that what row is inserted. Let me run this query. Great. One customer ID, then customer name tutor of team, then customer address line 1 Bangalore, customer zip is also showing, customer status is also showing, and customer creation date, which is this date, 7th February 2021. That's brilliant. So it's showing the customer table with data, the select query. Now, if I want to update the zip code from this table, from this record, then what command I will write? Update customer. Let customer underscore zip is equal to 560036, where first ID is equal to 1. Let me run this query. One row updated. Great. Now let me see, is it updated or not? I'm blocking this code again, and I'm uncommenting this code, and I'm running this code. Yes, it's changed. Previously it was 560037. Now it's 5060036, which is updated. Now I want to delete this record from the table. So I'm running delete command. Customer where cust ID is equal to 1. I'm running this query. One row deleted. Oh, great. Then if I open this one and I'm closing this one, if I run this query, no data found. That means record is deleted. So this is how insert, update, delete, select work in data manipulation language. Now the third one is DCL, data control language, which is grant and revoke. So this is specifically for multiple users in your database. Suppose in your database or in your database, multiple schema is there. Schema means multiple, you can say field. It's a big ground, biggest ground, and in that ground, one particular ground is for one person or like one apps. Another one is XX cost. Another one is AR. Another one is AP. Another one is GL. Another one is different things. So many small ground combined and created a big ground, which is database. So suppose you are creating a table in your apps ground and you want to give some access to that particular table to any other ground, then it's known as you have to give through grant command. You are giving the grant for that table to another user. Same for revoking. If you want to revoke. If you don't want to give after giving grant, and after some time you want to remove that grant from that table for that user, then you have to write only revoke, and it will take back the privileges granted from the users, or in that from the schema. So this is how grant and revoke will work. This will I will explain you later through examples. Now RDBMS. RDBMS stands for Relational Database Management System. RDBMS is a basis of for SQL and for all modern database systems like MS SQL Server, IBM DB2, Oracle MySQL, and Microsoft Access. A relational database management system, RDBMS, is a database management system, DBMS, that is based on the relational model as introduced by EF Court. Table. The data in a RDBMS is stored in database objects, which are called as tables. So I already explained you about tables. It's a object where we are storing data. RDBMS stored the data into the tables. So this table is basically a collection of related data entries, and it consists of numerous columns and rows. I already told you that in that this is a table structure, customer table structure, and in that customer table structure, this customer ID, customer name, customer address, and customer zip, status, creation date, these are all the columns. I created with only 6 columns, but there are many tables which consist of hundred of columns. Okay, so those are uh, part of table, and in that table, when you're inserting some record, that knows as record or rows. So it's a you can say that it's a matrix where column is there, and in that column some data is also there, and with the with all the data and with all the columns, you can say it's kind of matrix you are creating in the as table. Field. Every table is broken up into smaller entities called fields. The fields in the employee table consist of ID, name, age, address, salary. In this customer table, the field is customer ID, customer name, customer address line 1, customer zip, customer status, customer creation date. Those are the field of that table. Means this customer ID, customer name, customer address line 1, zip, status, creation date. With this all this field, you are creating the customer table. Record. A record is also called as a row of a data, is each individual entry that exists in a table. So this is a record. When we are inserting a data into the table with this with all the information which needs to put into the columns or fields, that known as record. So record is also called as a row of each of data is each individual entry that exists in a table. Column. A column is a vertical entity in a table that contains all information associated with a specific field in a table. So column, you can say the address. Suppose this is the column. It's a column, and in that column, already one row I inserted. That is suppose Bangalore. So address line one column consists of Bangalore. If I put the second row, inserting the second row with suppose Chennai, with suppose Kolkata, with suppose Delhi, with suppose any other address line one, that is known as column. So this is till this point. I guess everything is clear, guys. So now we will move our discussion to normalization, which is our last topic for this video. So database normalization. Database normalization is a process of efficiently organizing data in a database. You're creating a building. Suppose you are creating a building, and in that building, first what we are doing when we are trying to create a building in a field, what we are doing, what we did first, we plan for that building, how our room will look, how which is the entry point of our apartment, how we will construct the apartment, like where should be the door, where should be the balcony, where should be the window. Everything we are planned, then we put it into the blueprint, then we pass that to engineer, and engineer will create that building with that proper information, that this is how you have to build that building. This same logic will work for SQL also. When you are creating a table, it should not be like anything. You are you are creating a table with a chunk data, with a chunk table concept, with a chunk idea. You have to be proper. You have to be create efficient uh, table structure, so that your database will perform very quick. Suppose you create a building with the improper door positioning, like you want to you put your door beside of the main road, that is fine, but you are putting that door behind of your main road, then you have to uh, walk little more time for to reach the main road. So that is not good building construction. Same for table also. If you are creating a table with multiple columns, and that columns consist of some lots of data or lots of record, like more than 1 trillion, 1 trillion more than, then maybe your database will crash also when you are running that. So that's why both these reasons are worthy goals, as they reduce the amount of space a database consumes and ensures that data is logically stored. Normalization consists of a series of guidelines that help guide you in creating good database structure. Normalization guidelines are divided into normal forms. Think of a form as a format or the way a database structure is laid out. The aim of normal form is to organize the database structure so that it compiles with the rules of first normal form, then second normal form, and finally the third normal form. It's your choice to take it further and go the fourth normal form, fifth normal form, and so on. But in general, the third normal form is a more than enough. So we will know what is first normal form, second normal form, and third normal form. So let's start with first normal form. First normal form consists of three rules. First rule of first NF, you must define the data items. Second normal form, or second rule, second rule of first normal form. There are no repeating groups of data. The third rule of first NF is the final rule of the first normal form is to create a primary key for each table. So first rule of first normal form, you must define the data items. This means looking at the data to be stored, organizing the data into columns, defining what types of data each column contains, and then finally putting the related columns into their own table. For example, you put all the columns relating to location of meetings in the location table, those relating to members in the member details table, and so on. Like one of the example in the customer table, I put all the customer details into the customer table. The second rule of 1F, the next step is ensuring that there are no repeating groups of data. Consider we have the following table, let's create table customers ID, then I'm defining its number, then name, varchar 2, 100, age, number, and address, varchar, varchar 2, 100, then orders. That is also varchar 2. So this is a table structure. Now I am just running this table structure into the database and it will create the table. Table is created. So there are no repeating groups in this table. We have to do that one in the second rule of 1M. So if we populate this table for a single customer having multiple orders, then it would be something as let's inserting the record. The one record, second record, third record. And only the change is the only change is in the order field or order column. Now, if I run this query, it will insert 3 records. 3 records is inserted. Let me see the records into the database. Great. So this is looks like this. So if we populate this table for a single customer having multiple orders, then it would be something like this: 100, 100, 100, Trust 30, 30, 30, Bangalore 1, and only the orders. So it's actually um, following the 1NS, but we need to ensure that there are no repeating groups of data. So we are able to see here some repeating groups is there, like ID, name, age, address. These 4 fields are repeating for each order. So if we have to put this table in the second NF also, then we have to remove these repeating groups from our database. So we have to uh, divide this. We have to divide this table into 2 tables. How we can do this and do that one? Let me drop this table first because this is not following the 2NF logic. Drop table commands. I'm dropping this table. table drop. Now I'm creating the table with 1NF and 2NF customers. Sorry, for with 1NF, second rule, with 1NF, second rule. So I'm creating this one with this information: ID, name, age, address. These four fields. I'm taking these four fields, and then I'm defining one primary key, that is ID. The third rule of 1NF is it should be consist of primary key. It creates primary key for each table. So I am giving a primary key for this table. In that, ID is the primary key. So if I run this query, table created with primary key. Now if I want to insert this record, I'm inserting this record, removing the ordered data from this table. Run this one row inserted. Now if I query this table, only one record is there. I don't have to repeat the same thing again and again. And then this is the, now this table is following the first NF, all the rules. First rule is you must define data items. I am defining all the data items into the table. Second rule is that there are no repeating groups of data. If I am inserting record, it's not creating any repeating data into our table, so it is following the second rule also. The third rule is the final rule of the first normal function, creates primary key for each table. So I am creating the primary table key also in this table. So it's following all the three rules in this table. Now I am creating the second table because I removed the order details from this table. So I'm creating that order table here with ID with first with the first rule, the data items I have to define. So I'm defining the data items. ID is a number, then customer ID, that is also number, then orders, that is bar care 200, and then I am defining the primary key of this table. So that is also I'm defining ID. So if I run this query, then order table will create. Table created. And now I'm inserting the order data in this table. First is the ID. Second one is the customer ID, which is 100, which is actually, this customer ID is actually for this ID, means customers tables ID. So I'm passing 100 is a ID in customer table. So I'm passing the 100 here also as a customer ID. Then orders. Orders is first one is ABC1. This ABC1 I'm passing here in this table. And I'm removing this one. So if I run this, there are three orders. So I am passing three orders. So I am removing this orders table because it's already created. And I'm running this query. Okay. ID, customer ID, orders. Oh, sorry. It should be orders table. Three row inserted. Now if I query this one, I will able to see all the orders. So 3 records are showing here. So orders table and the customer table now following all our first normal form rules. Means it's defined data, all data items it defines. No repeating groups is there in these two tables. The third rule is that both tables consist of primary key. Now next go for the second normal form. So second normal form is the states that it should meets all the rules for first NF and there must be no partial dependencies of any of the columns on the primary key. What do you mean by that? Consider a customer order relation and you want to store customer ID, customer name, order ID and order detail and the date of purchase. Okay, let's see some examples. I'm creating a table. First, I need to drop the previous customer table. Table drop. Now I'm creating a customer table with cust ID, number, then cust name, varchar 200, then order ID, number, then order detail, varchar 200, then sale date, this date, then primary key I'm creating as cust ID, comma, order ID. This is a combination of primary key. I'm running this program, running this query, table is created. This table is in the first normal form. In that, it obeys all the rules of the first normal form. And in this table, the primary key consists of the cust ID and the order ID. Combined, they are unique, assuming the same customer would hardly order the same thing. However, the table is not in the second normal form because there are partial dependencies of primary keys and columns. Cust name is a dependent on cust ID, and there's no real link between customer's name and what he purchased. The order detail and the purchase date are also dependent on the order ID, but they are not dependent on the cust ID. Thus, there is no link between cust ID and the order detail of or their sale date. So, to make this table comply with the second normal form, you need to separate the two columns into three tables. So, first we will create customer table. So, I'm dropping this table. Now I will create the customer table with 2NF. With cust ID, number, comma, cust name, varchar 200, 100 and the primary key is cust ID. So I'm creating the customer table with this cust ID and cust name, 2 columns. Now I'm creating the order table. I already created one order table, so I'm dropping that one. Drop table orders. Will drop. Now I'm creating the create table orders with order detail. Order ID, that is number, order detail, bar char 200, and I am defining the primary key for this table. Is order ID. So I'm running this query, table created. So customer table created, order table created. Now there should be joining between these two tables. That is customer order. I'm creating another table, customer order, which consists of first ID, number, order ID, number, till date, date, and I am defining the primary key, which is first ID, comma, order ID. Now I'm running this table, and it will create the table created. So now we define 3 tables, customer order, which contains all the columns which we previously created in that table. And with that, this second normal form is also compiles all these 3 tables. Now the last normal form is the 3NF, the third normal form. A table is in third normal form when the following condition are met. It's in second normal form, and all non-primary fields are dependent on the primary key. So this is the last condition of the third normal form. It should consist, or it should be in second normal form, and all the non-primary keys should be dependent on the primary key. So let me drop this table again. Drop table customers orders and customer orders or orderings. So let me create one table. Create table customers. First ID, number, first name, varchar 200, date of birth is a date, then street is a varchar 200, comma, then city, that is also I'm putting varchar 100, then state That is also work at 200. Zip, I'm putting work at 200. Then email ID, work at 200. And then I'm defining the primary key of this table. This cust ID. I'm running this query. Table created. The dependency between zip code and the address is called as a transitive dependency. To compile with the third normal form, all you need to do is to move the streets, cities, and state fields into their own table, which you can call as zip code table. I have to break this table to make this third 3NF compile. So for that, I'm creating another table, create table address, consists of zip, state, city, state, and I have to define the primary key. I'm putting primary key as zip. So I'm running this query table and table created. So address table is created. The next step to alter the customer table as shown, as I will show you here. So I will drop this customer table first. Let me drop it here. Okay. I'm dropping this table. Yeah, table dropped. So now I am creating the new customer table with 3NF. Consists of cust ID, number, customer name, varchar 200 I'm putting, then date of birth is date, then zip, varchar 2, then email ID 2, and then I have to define the primary key, which is cust ID. So table is created. So previously customer table consists of address as well as the customer details. Now we break it to make it compile with 3NF. We break it to address table and the new customer table. The advantage of removing transitive dependencies are mainly twofold. First, the amount of data duplication is reduced and therefore your database becomes smaller. The second advantage is data integrity. When duplicated data changes, there is a big risk of updating only some of the data, especially if it is spread out in many different places in the database. For example, if the address and the zip code data were stored in three or four different tables, then any changes in the zip codes would need to reply out of to every record in those 3-4 tables. So it will be very big messy thing will happen in your database if you are not going for 3NF. So this is the data normalization, first NF, second NF, and third NF. With that, I am closing this video for now, and we will come by the next video very soon. Thank you.